Computers keep getting faster and faster, and yet we just keep using up more and more data and bandwidth and resources. The faster we can get it, the faster we use it up. And in addition to that, the whole world is built on a ton of infrastructure, and not everything's the latest, newest things. There's a lot of old infrastructure out there that we still depend on and use. One of the biggest trends we see is artificial intelligence. It's not one particular thing, it's going to be part of everything, and it's going to be everywhere. It's going to be running in the cloud, in big data centers. It's also going to be running on your watch and on your phone and on all kinds of devices, probably in the light bulbs in your house. So the ability to 2x, to get twice as much bandwidth and data across these pipes is going to be one essential part of the puzzle for growing and scaling all these amazing solutions that are coming out with artificial intelligence, with autonomous driving. All these things produce a lot of data that needs to go over a lot of small pipes that are out there.
GenXComm came to be from years of research at the University of Texas, Austin. My co-founder and I spent a lot of time understanding the fundamental limits of why communication works the way it does today and how we can make it much, much better. We worked on full duplex, a core technology that can make communication devices transmit and listen at the same time. Imagine that. No communication device out there today can do that at all in practice, and we have made it possible. By doing so, we've made this technology something that can be adopted by every device everywhere, improving the performance of networks for the future.
So our current radios are all half duplex. What that means is they take turns to talk. They either transmit or listen at a given time and in a given frequency. Full duplex is basically an ability to transmit and receive at the same time in the same frequency.
That big difference means that for Wi-Fi, you can get a 30x improvement in throughput. For things like cable, you can get a 100x improvement in uplink throughput. And latency going down by 2 orders of magnitude, from milliseconds to tens of milliseconds to hundreds of microseconds. All because you can do self-interference cancellation. You can do this technology.
The importance of full duplex is using the existing bandwidth to put more capacity through the channel. So be able to deliver more content or transmit more content over an existing channel. That's one of the big advantages, having symmetrical services where the consumer doesn't have to sit waiting hours to upload a very large video file because they have a symmetrical service into their homes or their offices.
One of the biggest breakthrough we had in developing our technology was we combined two mainstream research areas of photonics and RF. And we were the first one in the world to use a RF photonic solution to solve problems in the wireless and wired communication systems. With our technology, we provide 3,000% improvement in allowing a lot of devices to communicate with each other.
Think video conferencing, where being there over the network is better than being there in person, because the bandwidths are so high, the capability of displaying humans is so good. So various forms of collaboration, online education, and this is real-time two-way video. This is not downloading a movie. This is people talking in real time. So the latencies have to be close to zero. They can't. When you're interacting or collaborating or educating video, it has to be almost zero latency to work, and that's what's coming at the higher speeds.
To do edge AI, you need extremely fast, extremely power efficient, small computing devices, which is what microphotonics can do for you today. And to enable decentralized AI, you need extremely low latency efficient communication, which is what interference cancellation can do for you today. Combined, this powerhouse will change architectures in computing and communications.